Okay. Yeah, I guess I'm audible. So, hi everyone. Today I'm back with another contest discussion. Today I'm going to discuss this Algo Elite contest T6. Without wasting much time, let's get started with the problem one. So, yeah, the problem was gapful customer ID. So this problem was pretty easy. It was actual Goldman Sachs OA question. Let's start with the problem now. You work for a telecommunication company. Assign unique customer IDs to everyone. Okay. Okay. So okay. Yeah. Basically, this is just a story which is saying that we have given an ID which is in the form of a integer. Basically, it is saying a ID gapful ID. It is asking to find the closest gapful ID to n. N is given to us. N is an integer which is greater than or equal to 100 and going up to 10 to the power 5, right? Yeah. So it is asking us about gapful ID. Let's see what gapful ID is. A gapful ID is a number which has at least three digits and it is divisible by joining first and last digits of it. Consider a take number as 500, right? So if we take its first digit and last digit, which is 5 and 0, and we concatenate them, we get 50. And we all, as we know that 500 is divisible by 50, that means this 500 is a gapful integer, or you can say a gapful ID. So what we need to find is, we have given an integer n, we have to find a closest integer towards left or right, which is a gapful integer, right? uh, and in the problem it is saying that your task is to write a program that takes a customer id n and returns the closest gapful customer id including n itself if two numbers are equidistant from n. Let's say if this is n, the gapful integer, one is towards left and one is towards right, and let's say this distance is same. Kind of scenario, we need to return the leftmost uh, gapful id. Otherwise, we need to return the closest id, closest gapful id. Okay. As the constraints for this problem is n is going up to 10 to the 5, it's an easy problem. Let's consider its brute force solution first. As n is from 10 to from 100 to 10 to the power 5, we can check on both sides, like left side from 100 to n, and in the right side from n to 10 to the power 5. And in both sides, left side and right side, we can find a gapful id which is closest to n, and then we can just compare these left and right so that we can return the closest one, right? We have considered this left side, uh, in which we use this interval from 100 to n, and in right side we have used interval from n to 2e5. Why we have used this 2e5? Just to be on safer side, because let's say if as n is up to 10 to the power 5, right? Let's say if I take a worst case scenario when n is 10 to the power 5, right? We have to check on its right side as well. Uh, that's why I'm using this section 10 to the power 5 to 2 into 10 to the power 5 part, because I don't know that uh, gapful integer that might occur in this section as well. That's as we have to check on both sides, left and right. That's why if in worst case scenario where n reaches 10 to the power 5, I need a right section. That's why I'm just using up to 285. If you want, you can use up to 1e5 also, but just to be on safer side, I will be using up to 2e5, right? So the algo for this problem would be, while checking for left side, I will run a loop where I is going from 100 to n. I will concatenate the first and last digit of the number and get the concatenated number. If this I% concatenated number is equals to 0, that means if I is divisible by the concatenated number, that means this I itself is a gapful integer. Then I will update the closest left gapful integer. And for the right side, similarly, I can run a loop and update the first right closest integer, closest gapful integer. And after getting both these left and right ones, I can just compare these. Whichever is more closer to n, I will just return that. And if both are equidistant to each other, equidistant to n, then in that case, I will return the left one, right? Let's analyze this time complexity now. For left part, it will be big of n minus 100. And for right part, it will be big of kind of 2e5 minus n. So overall, I can say that the time complexity would be big of 2e5, right? And the space complexity would be big of 1 because I am not using any extra space over here. Let's see its code now. It's pretty simple problem. Already coded this. Let's see. I have taken uh, so I have taken n as input. I have initialized left as 1e9. I am checking for left part. My I is going from 100 to n. I am considering this. I am taking I. I am storing this I inside string s so that I can uh, access its first and last digit. And I have created that concatenated number as num is equals to uh, this is s dot sub str 0 comma 1 is the first digit, and this is the last digit of that string. I have concatenated that. I got the string, and then I have converted this to long using this stoll. This is a simple stl function which you can use. If I percent num is greater equals to 0, that means this I is a gapful integer. I have updated this left as I. Similarly, I have checked for right, and wherever I got a first gapful right integer, I have break the loop. And after that, I have just compared the closeness of both left and right. If this is the case, then I have returned left, and if right is closest, then I have returned right. Otherwise, I have returned left. This was pretty simple problem. Let's quickly move on to problem 2 now. So yeah, let's see this problem. So this problem was back and forth journey. Uh, this was actual Microsoft OA problem. This was a medium problem. I guess some of you might have faced some difficulty in this problem because of some technical issue in test cases. But leaving that aside, let's quickly see its actual solution now. In this problem, basically, the problem is saying you want to visit your friend who lives abroad. It's time to plan the journey. Okay. Yeah. Basically, it is saying that we have given a forward path from a point from a guy's original point towards its friend's his friend's location, right? This forward path is saying that there will not be any occurrence of south direction in this path. Basically, we have given a forward string, or you can say s, which is consisting of n e w. N means you are going in north direction. Like if you are at this point, you will put this way. If you are at this point and you are having e, you will go in east direction. If you are at this point, you are having w, you will go in west direction, right? So this is the input string which you are having. Let's see um, what we have to return in this problem. Yeah. Okay, we have to plan a shortest reverse path from friend's location to his that guy's original location. But in this shortest path, we have to keep some key points in mind that we don't have to uh, use already visited point, or you can say the already visited node in this path. Okay, and you have to return the shortest path possible. Okay, the size of input string can go up to 10 to the power 6. Yeah. Again, let's quickly summarize this thing. problem is saying a path is given to reach friend's position in the form of path string. Path of I can be north, east, west. South is not possible from forward path. Forward path from source to destination, a person is going upwards or in north direction. You can say it is not taking any south direction, which is the same thing. We have to return a shortest reverse path from destination to source such that it does not contain any point which is already been visited in the forward path. Same thing which I have already discussed. Let's quickly see one of the given sample test case. Let's say this is uh, the forward path given to us: N, E, N, E, N, W, 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 and N. Okay, let's try to visualize this thing on Cartesian player where we have x and y axis, and let's consider the original point, or you can say the original coordinate of the guy be origin, which is 0 comma 0. Okay, basically what I'm doing here is if guy is currently x comma y, and if the current index of the path is north, he will go from x comma y to x comma y plus 1, and if the current direction is south, he will go from x comma y to x comma y minus 1, which is not the case in the forward case. But still, if e is the case, then he will go from x comma y to x plus y comma x plus 1 comma y, and if w is the case, he will go from x comma y to x minus 1 comma y, right? Using these rules, I can simulate the path. So initially it was at origin at 0 comma 0. I got n, so it will go from 0 comma 0 to 0 comma 1, and then e, it will go from 0 comma 1 to 1 comma 1, then north, then east, then again north, then west, then west, then west, and then north, right? So actually the question was that uh, the first and the last character in the forward part should always be north. This was, I guess, mentioned in problem itself. But in some of the test cases, this was not the case, right? That's why some of you got confused. This was just a technical issue, but in actual problem, uh, all the test case should be in such a way that the first character and the last character of the forward string should be n. Okay, so let's try to solve this problem in that way only. Okay, and we have to find the shortest path possible without using any visited point, right? So for this particular test case, we can say that from if the initial source point is 0 comma 0, then the destination coordinate would be minus 1 comma 4 after simulating this current path, right? And while going from this whole path, we can mark these points as visited, right? And in reverse part, you can say that I can't use this point, this point, this point, this point, this, and this. But we can use this and this because these are source and destination points. Okay, let's try for the shortest possible path. One of the shortest possible path could be this, this, and this. And another shortest possible path can be this, going up to this part, this, and this. Because this is on Cartesian plane, there are only two possible types of shortest path possible. Uh, you can say their permutation as well. But let's try to explore only two paths of this type and on another path of this type. So the path one, which I am considering, is basically I am going from current x comma y, which is the destination point, to the leftmost point of the journey minus 1, so that I would not repeat the point. Then I would go in south direction the number of times I have taken north in the original path. Then I would just reach the origin. So that's how I can uh, consider the path 1, the first possible shortest path, which is in which is just go from x comma y to leftmost x comma that same y, then from that to that leftmost x comma 0, then from this point to 0 comma 0. This is the first possibility. And let's quickly see the second possibility, which can be go x comma y to the rightmost x, let's say x double dash, comma the same y. Then from that, go to the lowest level, which is same x double dash, comma 0. Then go from that to origin, which is this part only, right? South, 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 west, west, west. Okay, let's quickly consider both of these cases, both of these paths. In first path, I am going from x comma y to leftmost x minus 1 comma y, then leftmost x minus 1 comma y to leftmost x minus 1 comma 0, then from this to origin. Similarly, I have already written for uh, part 2, where I am going from x comma y to rightmost x plus 1 comma y, then from here to leftmost x plus 1 comma 0, then from this point to origin. Let's quickly evaluate both these path sizes. For length 1, for this particular first path, length 1 would be going from x comma y to this leftmost x minus 1 comma y. It would take me x minus this lx minus 1 plus this y number of south point, y number of south uh, steps. Then from this lx point, I have to reach this origin part. So 0 minus lx minus 1, which will be x plus y minus twice of lx minus 1. Similarly, I have evaluated length 2, and then I have just uh, wrote this pseudocode for this algo. Initialize x and y as 0. Iterate over the forward path to get the the leftmost x point and the rightmost x point. Yeah. Evaluate the length 1 and length 2. Whichever length is less, build that reverse path and just return that. As the length of the given string is up to 10 to the power 6, the time complexity would be big of 10 to the power 6, because I am just iterating this thing once, and I'm not using any external space, so the space complexity would be big of 1. Let's quickly see its code now. Yeah, second problem, right? Back and forth journey. I've already coded this. I have taken this input string, forward string. Then I have initialized the x and y coordinate at 0, comma 0 for the source part. Mn is my leftmost x point and mx is my rightmost x point in this forward string. I have iterated this string. If I am getting north, I have incremented my y coordinate. If I am getting east, I have incremented my x coordinate. Otherwise, if I am getting west, I have decremented my x coordinate. And at each step, I am kind of updating my leftmost x and rightmost x. And after this complete iteration, I have calculated the cost 1 and cost 2 in similar manner, which I have discussed. And then I have compared, if cost 1 is less, I have to just uh, go from current x comma y to the rightmost x plus 1, which I am achieving through this while loop. And while doing this, I am pushing E, because I have to go towards right to do so. That's why I am pushing E inside my answer string, and I am incrementing my x coordinate. And after reaching that point, uh, my cost 1 is for part 2 actually in this code. Yeah. And then I am going y number of times south and decrementing the y coordinate. Then I have to just read the origin. That's why I have used while x is not equal to 0. I have to go that much number of times west, and I have decremented x. Similarly, I have done this in reverse order. I have decremented x coordinate to reach leftmost x minus 1, then y number of south, and then again I have incremented answer with I have pushed the east direction to inside my answer string to reach the origin part, and I have just returned the answer string. That's all for this code now. Let's quickly Go to third problem. Okay, so let's continue with this problem 3. Let's see what it is saying. This was also a medium problem. Blue dart and parcel, right? Volume is max, yeah. In the city of Mumbai, wait a second, yeah. In the city of Mumbai, Blue Dart must deliver parcel along a single straight line. The town has n customers location. Each is represented by a positive integer indicating its position on the road. Multiple customer might share same coordinates, no problem. The company deploys delivery agents, okay, all starting from central depot located at coordinate 0, right? Okay. Every customer must receive exactly one parcel and there are n parcels available. Okay. Basically, it is saying that we are having a straight line, which is, let's say, let's take as a number line, which is having n coordinates where n customers are there, which are waiting for their respective orders. And at coordinate x equals to 0, we are having n parcels along with d delivery guys, right? And we have to find the minimum time to deliver all parcels to all n customers using these d delivery guys, right? And these d delivery guys can deliver orders simultaneously. Like if I am using 5 seconds, in these 5 seconds, all these D delivery guys can deliver these parcels so that we can achieve minimum time to complete the delivery, right? Yeah. And apart from this, we are having some rules that each delivery agent operates under these rules. Parsing loading. Basically, loading parcel from x equals to 0 would take 1 unit time, and also dropping parcel at some xi coordinate would also take cost of 1 unit time. And apart from this, if a delivery guy has to go from x1 to x2 for this distance mod, like x2 minus x1, for this distance it would take x2 minus x1 time because its speed towards left or right is 1 unit per second, right? This is given to us and we have to find the minimum amount of time required to complete all deliveries. Whenever you see a problem in which minimum time, maximum time, or counting is somehow involved, you can think of these 3 4 types of techniques which might be the solution for these type of problems. You can use binary search or dynamic programming or maths or some greedy approach. So we will also start with binary search approach for this problem, and we will try if this problem can be solved using binary search or not. Let's see the constraints. D and N are up to 10 to the power 5. That means we can't use big of n times D, but we can use somehow, and also we can't use n square also. We can somehow use n log n, which gives us some hint that there might be the case that we can use binary search. Let's see if it is possible or not. Uh, yeah. Basically, the problem is saying that we are having this again, same thing. We are having a number line where we have n coordinates, or you can say the n positions of customers, and at x equals to 0, we have all the n parcel and d delivery guys. We have to find the minimum time to complete all delivery, right? And in time scenario, uh, picking a parcel is taking us 1 second. Dropping a parcel is also taking 1 second. Speed of delivery guys unit per second, right? In given time t, let's consider in given time t, we can use all delivery guys parallelly so that we can deliver as many parcel as possible, right? And yeah, let's try that. If we are, let's try to write a function f of t which would return whether it is possible or not to complete all deliveries in t time using all delivery guys or some delivery guys. Let's see. Yeah, as we are having d delivery guys, let's say d1 d2 goes on, then dd delivery guys. We can use all delivery guys parallelly. Let's try to visualize. If I have like, if this is t and we have to consider the behavior of this f of t, this would return true if we are able to deliver all n parcels, and it would return f false if we are not able to deliver all parcel in this t time, right? If I increase this t time, that means by intuition you can say that after some time, like this you will reach 2 point t naught. After that, for all greater t's, it would return me true, because as I increase the time limit for this completion of deliveries, all the delivery guys can easily pick and deliver the parcel, right? So the behavior for this f of t would be false, 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 true, 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 right? And we have to find the minimum time to complete the uh, delivery, right? So if I am able to find that the first time f of t is true, then it would be the answer for the solution, right? And whenever we see this kind of monotonic behavior, like this is kind of false, 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 then true, 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 true. Like at this junction point, before this junction point, everything is was false, and after this, everything is true, right? To find this leftmost point, or to find this right, like first true point, we can use binary search. If you have, like, if you are aware about how to apply binary search on answer, right? Let's try to uh, somehow form this solution in binary search. As this by like how to implement this f of t, because we what we are doing in this f of t, we are trying to find delivery guys, like we can find the number of delivery guys required to complete the, basically complete all deliveries in t times, and if the number of delivery guys required are less than equal to d, I can return true, otherwise false. That makes sense, right? Okay. If I am able to implement this f of t, then I can just use binary search to find the first t which would return true part, right? And that t would be the minimum time after which I can complete all the deliveries, right? And which is the answer for this particular problem. Let's try to understand its pseudocode. I have initialized low with max coordinate plus 2, or you can say 1 also. Like you can take lower bound as 1 also. I have taken max coordinate plus 2. Why? Because on this number line, if let's say uh, in some at a particular time, like I have to find the minimum time required to complete uh, possible all possible deliveries, right? So the minimum time would be the highest coordinate, because for the guy, for one delivery guy standing at x equals to 0, he has to go to that max xi, right? Which would take max of xi time. And also picking a parcel and dropping a parcel would cost him a 1 unit time. So that's why I've taken lower bound for the binary search as maximum x coordinate plus 2, right? And the highest time, the upper bound for the binary search, you can take int max or long max or 1e17. I have taken 1e17 and initialize the answer as -1, right? While high is greater or equal to low, this is just a standard binary search on answers template, which you can find anywhere and you can learn. This is simple. If while high is greater or equal to low, we have calculated the mid. If f of mid is turning me true, that means I have to restrict the upper bound towards the left part. I have updated the high as mid -1 and updated answer as mid. Else low is equals to mid plus 1, because if this mid is giving me, like if this is the region L, R and this mid, if this mid is giving me true, that means this section will definitely give me true for all the possible inputs. That's why I have to shrink this inputs shrink this search space L to R as L to M minus 1. That's why I have updated that high with mid minus 1. Otherwise, I have to update the low as mid plus 1. Right. And after that, I just have to return answer. So going to this time complexity part, let's see the implementation of function of t, right? Yeah. In this implementation, I have already discussed that I will be using the count of delivery guys required to complete all possible deliveries in t time, right? I have initialized count as 1 and taken the previous x coordinate of that particular delivery guy as 0, and I have taken time left as t because that particular delivery guy has t time, and we have to see like how many uh, delivery he can complete in this time, right? So time required for completing the ith delivery would be 2 plus xi minus the previous x, because he has to go from that previous x coordinate to that xi, and apart from that, uh, 2 for picking and uh, dropping that parcel. That's what time required is this. And if this time required is less than equal to the time left, then I can update the time left as time left minus equals to time required, and x as this x of I, because now that particular delivery guy have reached this particular x coordinate from this previous x, right? And else if this time required is less than is greater than time left, that means this delivery guy can't complete this particular ith delivery in this t time, right? That means I need to consider another delivery guy for that ith delivery, right? Okay, that's why I have incremented the count of delivery guy. And now for the new delivery guy, initial timelet should be t, and now I this new delivery guy has completed this ith delivery, so I have decremented time required from this t and updated the previous x as x of I. And after this whole loop has completed, I am having my count of delivery guys required to complete all deliveries in this t time. If this count is less than equal to d, I will return true, otherwise false. So that's how I can implement this f of t in big of n. So that's why you can say the overall time complexity would be uh, big of n log of 1 is 17, you can say, which is almost 60, you can say. So it will go up to almost 60 times n, and n is up to 10 to the power 6 or 10 to the power 5. Let's see, n is up to 10 to the power 5. So overall time complexity would be big of 60 times 10 to the power 5, which will be in worst case scenario at most 27, less than 27, which will definitely not give me TLE. So this solution would definitely get accepted. The I'm not using any extra space, right? Let's quickly verify. Yeah, I'm not using any extra space for the complete solution. That's why the space complexity would be big of 1. Let's quickly see its code now. Button parcel. I've taken N and D as input. I have taken all N customer location and input. Right. I have sorted these x coordinate because I have to apply binary search on these, and I have implemented the check function, that f of t, using lambda. This is here I have used time left type of implementation, but here in the code I have used the current time. There is slight change only. You can easily understand the initial time taken, the current time taken for this current delivery guy is 0. Count of current number of delivery guys is 1, previous x is 0. I am iterating over x coordinates. Time required x minus previous x plus 2, which I have already discussed, if this current time which is already used by the current delivery guy plus this time needed is less than equal to the k or the required time in which I have to uh, complete the deliveries. If this is the case, I can update the current time, the time used by that delivery guy, and the previous X. Otherwise, I can simply increment the count of delivery guys used, and the current time used for new delivery guy would be X plus 2 definitely, and previous X I can update it as X, and after this complete for loop I can just simply return count is less than equal to D or not, and this while uh, low as maximum x coordinate plus 2, high as 1 is 17, answer as minus 1. While high is greater than or equal to low, I have initially calculated the mid. Check the value of this function at midpoint, and I have shrunken the curve space here and updated the answer little low as mid plus 1 here, and at the end of this loop I am having my answer as the minimum time required to complete all deliveries using this D delivery guys, right? So that's all for this problem. Let's quickly go to the next problem now. Okay, let's proceed to this last problem of the contest, clear pixels. Before starting this problem, I want to tell you that this problem was from actual DShaw's OA, and this is pretty hard problem. Let's start its explanation now. Okay, some developers are working on clarification of an image with n pixel where the value of ith pixel is represented by pixel of I. Basically, we are having an array pixel which is having n number of elements, and pixel of I is representing the ith pixel. Okay, an image is clear if array pixel has a padding of some number of zeros, possibly none, in prefix and suffix, and non-zero part of the array, say from our index I to j, starts from prefix pixel of I equals to 1 and strictly increase for some key steps of 1 and then strictly decreases. Okay, basically it is saying uh, yeah, a clear image is the one whose n pixels are forming a mountains type structure. Basically, it can have a padding of 0 in starting, then it should for some number of pixels, and then for some time steps it should strictly increase by one step each, reach to some kth position, and then after that it should decrease by one for each step, reach 0, and then it should have some non-zero, like 0 or more padding of zeros. Basically it is saying a clear pixel array would look like this mountain, which would be having some kind of 0 0 0 0 0 in starting. This can be of length 0 or more. Similarly in right side it can have 0 0 0, some kind of padding in this form, length 0 or more, whereas this mountain type structure would be something like 1 2. This is just an example, right? This type of an array is a example of clear pixel, right? And we need to find the minimum number of operations needed to make the given array, the given pixel array, clear, right? And I have already explained that clear pixel array would something look like this, a mountain like structure, right? And in one operation what we can do is we can it is given that in single operation a developer can reduce any pixel value by one. Okay, so this is the case, right? Okay, and the constraint for n and pixel I is n is up to 3 times 10 to the power 5. Okay, and pixel of I is up to 10 to the power 9. No problem. Let's take an example which something like this only: 0 0 0 padding, then 1 2 3 4. then 3, 2, 1, and again padding. Mountain like structure. This is a clear pixel array, which array would look like mountain like structure. Let's try uh, to somehow get intuition for this problem. What we actually want, find, like, we need to, let's say, let's take this as example. 1, 2, 5, 2, 1, right? uh, we need to minimize the number of reduction operation. We can think like, we can only we can only get minimum number of operation if the cleared pixel array is having the highest mountain peak, right? I think that this should make sense for everybody, that if the mountain is having the highest peak which is possible of this type, then, because if this is the origin, let's try to visualize this. If this is the original array, if I am plotting the n pixel values on coordinate plane, and if this is the required cleared pixel array, in this case you can think like, the number of reduction operations, the number of operations needed to convert this array to this particular array is the difference between the values, this value, this value, this value, this value, this value, like for each ith pixel, right? So if we need to minimize the number of operations, that means we need to minimize the difference between these points. Like this padding should be zero. This padding would be zero. This difference is uh, this difference is fixed. If I can somehow increase this height, like if this can also be the mountain. In this case, the cost is high. If I increase the height, this will be the clear pixel array. Cost is this. But if I increase height to the peak, like the highest height I can achieve, in this case, I will be having the minimum cost. This is the greedy approach, or the greedy observation which we can use in this problem. If somehow we can find, like if we are able to find the highest mountain height we can achieve, then somehow we can manage to find the minimum number of operations needed, because then the minimum number of operations is just the sum of original pixel array elements minus sum of elements of this clear pixel array, which is 0 plus 0 plus 0 plus 0, and this is 1 2 3 goes on till h height, then h minus 1 goes on till 1, which is simply, if you can try to understand, 1 to h, then h minus 1 to 1, this is first sum of first h natural numbers, and this is sum of first h minus 1 natural numbers, h into h plus 1 by 2, h minus 1 into h by 2, and if you calculate the sum, it will be h square, right? So the minimum number of operations needed is sum of pixel array elements minus this highest peak square, and the question has been changed to just find this h value, right? So let's try to calculate this h value. Let's say, uh, let's see how we can find this h value. Let's say for each index, I am trying to find the left height and the right height I can achieve from both ends, right, of the mountain. If somehow I get the left height and the right height, this is obvious. If I have to create a mountain at this particular index, like peak at this index I, this would look like this. If the left height is this and right height is this, I have to consider the left one. And if left height is greater and right height is lower, then I have to make the mountain like this, right? So for the peak of mountain, I have to consider the minimum of left height and right height as the height of I, like H of I, but let's see, like, let's see what H of I is representing. H of I is representing the height of mountain I will be getting if I am considering the ith index as the index of peak of for the mountain, right? H of I is that thing, and I have to greedily choose which one index should be used as the peak of mountain, right? So I have evaluated this h of I, and after this I can iterate for each index, and I can uh, update the maximum peak height as max of maxi comma h of I to find the maximum mountain height. And at the end, if I am having the maximum mountain height, I can simply return the sum of elements minus h square, right? Let's quickly see its pseudo code now. Uh, I first have to pre-compute left height, then right height array, and then just I have to evaluate h for each index, the potential height if I am choosing the ith index for the peak of mountain, then I have to update the maximum height for the mountain, and after having maximum height I can just return sum of pixel elements minus maximum height square, right? Let's see its time complexity. Pre-computing this left height and right height would take me big of n and big of n. This loop is also big of n, so it will take me big of 3n, which is 9 times 10 to the power 5, which is almost 10 to the power 6. Space complexity would be big of 2n because I am using uh, left height and right height arrays for this. Let's quickly see its code now. Clear pixel, right? Here I have taken n as input, then pixel array. Then I have created left peaks and right peaks array. Okay, let's see how I have calculated the left peak and right peak. So, uh, leftmost height and rightmost height should be the minimum of that pixel value, comma, the value I can get if I am starting with 0 at initially. Like, let's say if I am uh, first index to be the uh, one height, and then strictly increasing that thing. That case, left peaks of I is equals to the minimum of k comma pixel of I. Similarly, I can evaluate the right peaks, initializing the k as 0, k plus plus, and right peak of I is equals to minimum of k comma pixel of I. And then I have uh, initialized the mountain peak, the height of mountain as 0. I have iterated all the indices and updated this mountain is equals to max of mountain comma minimum of left peak and right peak, which is the height of mountain if I consider this ith index to be the peak one. Then I have evaluated this sum using the accumulate stl and return sum minus mountain square. I hope this question is uh, making sense to you. Let's quickly re-summarize all the solutions. Basically, in the first solution, the first problem was pretty easy. The brute force solution is I just have to check for left section, which is from 100 to n, find gapful integer closest to n, and also in right section, find from n to 2e5 or say 1e5, find the closest closest gapful integer to n, compare both of these closest leftmost and rightmost integer, which one is more close to n, just return that, and if both are equidistant to n, just return left one. Second problem was pretty observational problem. in which we have given a forward string which is representing the path the guy has taken to reach from its original location 0 comma 0 to its friend's location, which is finally x comma y, where we have simulated the path to find the leftmost and rightmost x coordinate in the path. And after that, we have considered two paths to be the potential shortest reverse path, which is path 1 was in path 1 I'm going from this x comma y to leftmost x point minus 1. Then south, south, south. Number of times I have taken the north in forward string. Then just return to origin. In second path, I am going from this current x comma y to rightmost x plus 1, comma that same y. Then same number of south directions as the number of north in forward direction. And then just reach the origin. Consider both this path. Find the length of both paths as L1 and L2. Compare these L1 and L2. If L1 is less, build the reverse path for this part for path 1. Otherwise, build reverse path for part 2 and return that respective reverse path. And in third question is pretty standard binary search on answer problem where we have to find the minimum number of time required to complete all deliveries using D delivery guys. We have used we have used f of t function, which is returning me true if I am able to complete all n deliveries in t time, otherwise false using D delivery guys. And to implement that thing, I have used the count of delivery guys used or required to complete all n deliveries in this t time. If this count is less than equal to d, then I have returned true, otherwise false. And using that f of t function, I have simply used binary search on answer to find the lowest time for which this function is returning me true value. And the last problem, in this last problem, this problem is based on mountain array where we are having some padding of zeros in left and some padding of zeros in right, and in the non-zero section we are having a mountain which is strictly increasing till k steps and then strictly increasing decreasing at each step. To reduce the minimum number of reduction operation, I have to greedily I have to smartly choose a index where the height of mountain is highest, because the number of operation needed to convert the pixel array to clear pixel array was the sum of pixel array elements minus the height of mountain square, right? That's why I have greedily uh, considered left height and right height for each indices. For each index, updated the height of I as minimum of both of these, and then updated the maximum height a mountain can have for each index. And after this for loop, I am having my mountain height. I have just returned sum of all elements minus sum of mountain, which is mountain height square, mh square. That's all for this editorial. If you are having any kind of doubt in any problem, you can ask in comment section. That's all for today's video. Thanks for watching. Bye bye.